There it is, the third generation of VXwheel onewheel, this time fully compatible with the XR parts, rails, bumpers, foot pads, hub, anything you want except for the battery and controller box. Fully compatible with the Float Life accessories like banks, additional fenders, Enduro tire, anything you want. 20S 2P battery design, working at 84 volts maximum, swappable battery, splittable into packs, legal to fly, and so much more. So this is kind of the best option you can go right now when converting an XR to a VESC. I finished this project about 2 months ago, and straight away after a few days of testing, it went to Algarve onewheel tour, which is more than 300 kilometers on mostly unpaved trails, dirt roads and stuff. It performed great. I made 4 flights to get it there and back. Everything was smooth. There's a lot to talk about it. Let me quickly show you first how it looks inside in the front. 1/5 of the battery in front, the little foccer controller, voltage display in handle, as in my previous design. Custom lights. I'm gonna talk about custom lights next time. Also rear lights. Then let's look at the battery compartment featuring the Ennoid BMS and splittable VXwheel battery design. It's a lot I want to show you about the front and the rear battery compartment design. I just don't want to forget telling you that if you use the VXwheel battery design for this, you're gonna also need to use my design of battery box and front controller box, because it's all connected. Either you put the whole project together as this one is, or it's not gonna work. Let's start by explaining the battery, because that's the main difference between other VESC XR conversion projects, and hopefully this video will help you make yours as well if you own it. Making threads in the battery housings. You have to do it very slow, because otherwise plastic will melt and there will be not much of your thread left, just a bigger hole. Also, you don't need to do the threads very far, just for the start. The rest of it will be self-tapped with a screw while assembling it, and it will hold even better. The process of making a battery for a VXwheel XR conversion, it's very similar to the initial VXwheel battery design. It features 3D printed plastic enclosures. The difference is we had 3P in the initial design, now we have 2P because we have 20S. All the boxes are marked with numbers 3, 4, 1. Additionally, I have marked the positive and the negative of the cells, so you really can't miss anything. You have numbers, you have positive, negative. Should be easy. Measure each cell voltage, because you really don't want to find a bad cell later when you already spot weld them. If any of them seems to be not fitting with the voltage, don't use it, because it's a big chance it will cause you problems with unbalanced pack. Let's start with pack number 1. There's the positive, so you should put positive here. We are going serial connection, so of course next one goes negative up, again positive up, again negative up. Just for the double check, you have the negative here and the negative here, so this is how it should be. Positive here, negative here, and those two like this. Number 2, again positive here, negative here. Do the same for number 3, 4 and 5. Double check it at the end. Don't forget about additional fish paper isolators on every positive side of the battery, because under this shrink tube there's already the negative side, and you really don't want a nickel strip or anything else to damage it and make a short right here. So additional isolation is extremely important here. Both sides, every positive terminal should look like this by now. What about the connections? If you have the main positive and the main negative marked, that's the place where the wire gets out, so that's the main positive and negative of each pack. If I write it down, you can see I have positive here, negative here, and 4 of the cells that are in parallel, so there's actually 4, not 8, if you design this. So this is positive, negative, positive, negative, positive, negative, positive, negative. This is how the nickel strip needs to be done. And then you have the exit wire and the other exit wire. I'm going to talk about the balance leads a little bit later. You need to connect them to each of those connections, but where to place it and that I will explain later. Now I can only tell you the balance lead is gonna exit where the bigger gap for the cables are, no place here, so this is just the main, and the balance is on this side. It all makes sense once you make the board together, and you will see that. Let's weld it up. Last pack, I'm gonna show you how I did those 4 already. Tip number 1, you should avoid sharp edges like this on the positive, because they might slip under the isolation ring and touch the negative pole. You really want to avoid those. I just cut the sharp edges away. Since the P groups there's gonna be little to no current flowing, I'm gonna put connections like this first. I'm using 3 welds on each cell. The positive is not a problem, you can weld wherever you want, where there is space. While on the negative, I suggest you do it like this. 2 welds on one side and 1 weld on the other side. Leave the central part free, because on the negative top of the cell, right under the center, the internal tab that goes into the cell is welded up, and if you weld exactly on that spot, you might damage the internal tab, so it's not good. Avoid that if possible. Okay, let's repeat this on those 2, and then I will show you how to continue. So as said, the high current is gonna go in this direction, not through the P groups. So that's why I made those connections first, so they're closer to the cell. Now I could add the connections like this, but as said, low current will be here. So I'm gonna do a cross so that this cell goes here and this goes here. This will actually double the nickel strip thickness in the direction of the current, while still connecting the P groups that need to be connected. And we'll get something like this that I already made on 4 packs. Let's do it on this one as well. So that's one and that's the other. Don't need to press the welding pen too much, because actually you need some resistance to make a weld. If you have perfectly pressed contact, it's not gonna weld as good. Again, leaving the central part of the negative pole a little bit free. That's it for this side. All are done. Let's move to the next side. Now you really need to be careful not to do a mistake and put a nickel strip here, because you will short them, or here. We only need to connect the central two ones, and this is gonna be the main positive cable going out, and this is the main negative going out. So let's do that. Same system, this direction first, and now we're making a cross. I'm using 0.15 8mm nickel strip, which makes us actually 2 layers of nickel strip in the direction where the current is flowing, so that's 0.3 and should be enough. All are done on this side as well. So now we're gonna do the output cables. As you can see, it's a total mess around here, but this only means one thing, that I'm working as fast as possible getting the new battery design ready. I already made wires for pack number 1, pack number 2 and pack number 3. I'm going to show you how the wiring is made on pack number 4, and then pack number 5 is also left here because it's gonna go in the front box. Let's see how to finish this and add the main positive, main negative and the balance wires, as well as the temperature sensor that's gonna be on pack number 1 and pack number 5. On my previous VXwheel design, I would be putting the cable through those holes and soldering it on the cells. While on this design, I am very limited on this space. This is why the covers are very thin, so there is not enough place to put a thick cable up here. This is why I'm doing that in a different way. I start with 2 nickel strips and I put them together. To do that, you should lean them above some aluminum plate. Don't do it above the table, because you will burn the table and the weld is not gonna be good. You're gonna weld them up and they are not gonna stick on the aluminum plate. I cut these sharp edges away. The soldering is not gonna stick well on those sides where you are welding, but on the other side it's gonna stick much better because the material is cleaner. So let's solder the wire on this now. I'm using 12 wire gauge silicone wire. Next thing, you put solder on the tab. Let's put the silicone wire on the tab, and you can see it's 2 tabs. I put on a piece of shrink tube, put these tabs through here, just like this, so that the soldering part is hidden inside here. Then I'm gonna first use just one of those 2. Always get rid of the sharp edges. Let's spot weld just the first layer. As said, on the negative pole, it's not recommended to do it in the center. Now I'm gonna use a tap to connect the P groups. Now I put this other tab that's left across it and weld it once again. And at the end I'm gonna put another tab across that one. That being done, we have now 2 connections like this and 2 going down to the wire. This should be thick enough for the currents planned here. And there you have the cable. It must fit exactly inside this connector, meaning I'm gonna cut it somewhere right here, solder the 4mm bullet connector, and you will see how they join together. Might be easier to solder this connector on the wire before. I also did this on some previous specs, but you really need to take care of the exact length of these two connectors to join together. So I'm gonna do it this way right now. Like that. Put on some string tube. As you can see, it fits perfectly, because you need to leave space for the covers, and then it needs to be exactly aligned. Same as here. There's more space here on the positive side. That's why we should isolate this better, because there's gonna be other cables. So I'm gonna cover this up completely with a shrink tube. And again, one layer down, one layer across, the other layer down, and the other layer across. You must never spot weld here or here, always above the cell tab. Otherwise you will burn this isolation and make a short here between the positive and the negative. It doesn't matter if there is fish paper on, only above the cell tabs. And that's the positive one. Now let's add the balance cables. Connector with silicone wires, some quality ones. So we're gonna use that. I put some cable wrap on it so it's nicer. The balance leads go where there is this bigger space for cables, so not on that side but on this side. As you should know, this is the positive going back to the negative. Be sure to measure those wires before connecting them. The main positive goes here, the main negative goes here, and the three in between goes here, here and here. Okay, I connected the main positive one. Now let's find the next wire, which one of these is it. As you can see, that's the next one. And if that's the main positive, the next wire goes here. I'm gonna put a piece of shrink tube for additional isolation just here where it crosses the positive tab, so we have double isolation. That hole, those two and this one, is for the screws of the cover, as you can see here. So those two and those two are left for the cables to pass through. So I'm gonna route this cable through this hole like this. You have it here. Now be sure to leave enough space over this, around this hole, because there's that guy coming here. Okay, so route the wire like this, additional isolation over the tab. Once you flip it over, we're gonna just solder it here. Next one goes here. It's this one. Okay, let's shorten it and let's add additional isolation again over this positive tab. Fourth wire goes again down. That's the fourth one. Okay, for this I'm gonna isolate all of this that's going above the other contacts additionally, something like that. Switch it over and solder it right here. Okay, now the bottom part is done and we can already install the cover, but let's wait and first finish the wiring. This one goes here on the main negative. That's it. This is how you should connect the balance leads. Use something like that, a hobby cell checker, to check if you did your job as you should. And you can see all the cells are here, all the voltages match, so this is how it should be. One other thing, I'm gonna install temperature sensors on pack number 1 and pack number 5. I'm gonna show you that later because this is pack number 4 and that there's not gonna be any temperature sensor here. So we can cover this one up. On this design it's very important to use flat countersink screws, and that is because we are extremely limited with space on this direction. Now be very careful not to damage any cables with the screws. This one's quite close, but it's still away from the terminal. This one also, so just make sure there's enough space around them. This is how the pack is gonna look, all covered up with covers. Nothing should stick out, there should be flat, no screws out. You will see why this is very important later. Have the negative, positive cable and the balance lead. Basically all of them are made the same, so I'm gonna just assemble the 5th one and only gonna show you how I install the temperature sensor. So that's the temperature sensor I'm gonna use. Why I chose this one? Because it should be fully compatible with the Ennoid BMS system. I just extended its cables. I'm gonna add a shrink tube over them so they don't short with any of the battery terminals. The sensor will go out the same way as the balance cables do, with some thermal conductive paste. Like that, and then just outside together with the other cables. As you can see, what's the difference of this pack, it's number 5, is that the side where the balance leads go out is close to the main negative and not to the main positive. You really should be careful about connecting the balance leads depending on the cells, because this side is not always near the positive or near the negative. So this is how you install the temperature sensor. I will just leave the wires out now. I'm gonna use a connector later. That's it about the battery design. I hope you learned everything you wanted. Next video, assembling the battery in the controller box and everything else. So if you have questions, stick it in the comments. I'll try to answer it next time.